Good to go. So obviously still in exercise 5, and as I was mentioning before, I'll just kind of mention it for the sake of the video. That way, if anyone that wasn't here, of course, still gets the announcements. Essentially, I'm kind of giving 2 weeks to make this model. Obviously, this week formulate it, and really next week to start laser cutting, or even this weekend to start laser cutting, and start making the model. Right. Obviously, Tuesday and Thursday of next week, I won't be doing any tutorials. Basically, just aiding, right, in terms of putting stuff together. Keep in mind that the print lab upstairs in 645 also has large areas to work and make models too. So I can definitely go back and forth between this room and the other classroom. However, I've been also teaching Bohuslav's D2 class, and it reminded me of some other things that you might run into. So I didn't want to rob you guys of that as well. And just wanted to kind of go over, again, some of these really tricky elements. For instance, like this curvilinear one that has a slit through it, this piece right here, and just kind of wanted to show you how to make them. And to be fair, there's different ways of making something, right? They don't necessarily all have to be done in a folded manner. In fact, we can even use some of the previous tools that we used in the topography in order to continue. Last time in part 3, we basically talked about how you can make 2-dimensional jigs. You can print out things and just line it up to the paper and cut, right? And that arguably makes things a lot easier. And just for a reminder, yeah, we don't want to cut any of the dowels or honestly the beams on a laser cutter. It's just going to make too thin of strips, and it usually looks ugly, and it kind of actually bends around. And you might as well just get some dowels and get some correct measurements. So we did that last time. So I'm going to get rid of a few things. I have a copy over here, so it's not really a big deal. But essentially we talked about unfolding a little bit last time, what we could do with stairs, jigs, all those kinds of things. But I really haven't talked about some of the harder curvilinear elements, so I kind of want to do these 3 today. So I'm going to take these out and basically show you some more advanced stuff. The first one that we can do, and you may notice, I mean, we might have to ask ourselves a question here. How thick is this? How large is it? Because, well, to be fair, the material thickness that we're using, we could just choose a bigger material and fold it, right? I mean, not the end of the world. However, here, that might be impossible, right? We can't get a material that thick on the laser cutter in order to laser cut it. In our case, a couple things that we can do, and of course it froze a little. We mentioned last time that we could basically unfold this. So I just want to show you what it looks like unfolded. So unroll surface. I'm going to go ahead and keep properties and see what it creates. Right off the bat, not exactly usable, right? At least altogether as one piece. However, actually not too shabby either, right? In terms of at least the piece that it is. Obviously, we're seeing kind of this double piece going on right here. And to be fair, we could cut that as in 1, 2, 3, 4, 5 different pieces. Another way to look at this though, guys, is you can unroll just a simple surface. It doesn't necessarily have to be a poly surface. So you either have to have a completely closed surface or one surface to unroll surface. And I didn't even get to mention that to the D2 yesterday. There's kind of things, general rules, if you will, but one thing I forgot to mention is that you can actually explode the piece first. So for instance, perhaps I want to use the material thickness and I really just need the unrolled of one side. That way I can potentially cut it and then just roll the material itself, right? I may even have a material that even matches this. So, and if you don't remember what it was, you can do a dimension, DIM, and get pretty close and see how big that is. Right now it's kind of giving me a linear move on that one. Fake it till I make it to probably about 0.5. So we're thinking about 1/2 inch, so that's 1/16 of an inch. We can definitely get material that's 1/16 of an inch. So it might be actually easier, instead of unrolling and honestly trying to fold that, it looks pretty online, but as soon as you start saying cutting this out of cardboard, let's face it, the fold itself actually takes up some space. So, I don't know, that piece right there might look real janky, real inaccurate, right, I should say. So actually the better way to do it is to just cut it on one surface and actually fold that surface the way that it needs to be. However, we can explode it first. So explode. I'll take the one that makes the most sense, right? So for instance, typically I pick the one that's a little bit longer. And in this case, we have a pretty orthogonal shape. You'll see that, you know, like I don't have a single surface on that side. Let's see if I have a single surface on the other side. Maybe I do. Closer. Right, definitely have some pieces available. Sorry. There we go. And yeah, obviously we have some pieces in the way. But to be fair, that's pretty small, right, to say the very least. So I could take these two, even though they don't have any lines on them, even though there's not really any folds on them, I can still unroll that surface. Ooh, I can spell unroll correctly. And you honestly can take either or. However, it does have to be one at a time. So either a closed object or a single surface. So that's kind of nice because once I do that, what it'll basically do for me is get that entire length, right? And it'll even show the holes that need to essentially be cut. However, I do still need another piece, so let's do that again. I need, oh, wrong side. This piece. Ooh. So I'll take that one as well and basically stitch them together. So in my case, I could take that one whole piece and actually use that piece as an indicator as to where I should even score or start to cut these. So definitely not bad there. And hopefully that makes some sense, right? It's actually a lot less work, right? I mean, I just have to make one surface. I do have to think about it a little bit more. I also can't use something like basswood to like bend basswood, right? You can actually bend basswood, but it takes like a steamer. I don't know, I used to just boil water and kind of like put my basswood around it, and it eventually will bend, and actually once it dries, it stays in that basic shape. I mean, if we wanted to really get fancy with it, we could even make a template, right, based on this. Basically using that shape, make 2D. That basically, now I can basically print these together. That way I can even bend it to a shape, right? So I mean, there's an endless amount of possibilities, but I would say that's a little bit more advanced. Don't get me wrong, you'd probably get some brownie points for bending some basswood, right? I mean, if you started to implicate those things and did it really well. But this might be just useful in general as you're trying to fold this, right? So you may want to even print that out or even have it on screen. That way, oh yeah, it's supposed to bend this way. Oh yeah, it's supposed to bend that way, at least compared to the circles and the cuts that are involved. And mine's pretty crazy. I got a lot of cuts in mine, and honestly, some very weird cuts. So it doesn't make any sense to try to fold those silly little cuts. It's just not going to work. And in fact, even the material is going to get in the way with, say, like cardboard. However, the next piece, obviously from here, make 2D. And essentially we'll have that piece to cut. Now this is technically the one that I would cut. So I'd go to my layers, cut, or select all these. Definitely want to cut those. However, these ones in the middle, or especially the ones that I'm going to fold, right? I may want that to be actually a score line. So need to explode it, possibly even ungroup it, maybe even explode it again, as I learned yesterday. Sometimes they're under multiple. So right click and change object. That would be good for the laser cutter. I would even probably laser cut this. Again, just kind of, I mean, why not? If I had space on my material and just kind of remembering it as a template, you definitely could. Do you guys know what I mean by that? Like, for instance, like if you put a rectangle around it and I cut this out of the rectangle, then now I have this shape that I can actually put my material inside and even kind of guide it. Especially if it was basswood and I was just steamed it, I could actually even put it in there and kind of keep it there to hold it. You know what I'm saying? I don't know. I know some of us are furniture designers out there, and we You've definitely enjoyed and probably know about some furniture where they really bend multiple plywoods together. And that's, of course, they use a template, right, and use a lot of pressure and steam in order to remain and retain these shapes. But we can do that too. So again, a little bit more advanced, but wanted to throw it out there that, of course, it's still possible. The next interesting object of the day. Oh, also I wanted to mention there's other ways that you can make this. So like we did the topography and we used contours, another way of basically making some of these shapes is kind of what I call a 3D printing method, right? To where basically you're making each layer and essentially just laser cutting all those layers and gluing them together to make a solid piece. So one way that we can do that, let's say we were using 1/8 chipboard and we were going to essentially stack all those pieces of chipboard in order to actually get this maybe very unique cut, and that's definitely something we can do with this method. What we would do is contour again. We'll choose that direction instead, this time actually in the Z direction, so from top to bottom. And for my thickness, I'll choose 1/8, so 1.125 inches, enter. It's going to go ahead and do that for us. Hopefully, nice. Probably too many lines. In fact, I forgot. It's at true scale, right? So it gave me a shit ton of lines. Let's try that again. Actually, in our case, we would need to convert that to our 1/8 scale model. So that would be a foot. Let's try that again. Contour, choose the direction. And usually I just choose the direction of the model. And in my case, I'll choose 1 foot. So that is essentially all the layers that we need to cut out in order to glue them together and paste them. And what's kind of nice about that is obviously it reveals, well, I'm going to have several pieces involved. Now that might be a little too much, and to be fair, that's, not the end of the world. I'll take this piece, turn it basically into a cut first. And well, the hard part is really more online, right? Obviously I could take one, and actually I could take the one that is actually working. I don't have to actually take the ones that aren't working. And I can just copy this one several times. 1, 2, 3, 4, 5, 6, 7, 8. So I really don't need the rest of this. Again, I mean, why work harder when we can work smarter? Oop. And get rid of the things that we don't need. So I've basically simplified it down into two pieces, right? Essentially only needing 2 of these and 6 of those. So obviously I could go back to my top view and set those up as a laser cutter as well. So that might be a game changer for some. And keep in mind, I forgot to mention this, you can get very close with a laser cutter. Like this, even at Texas Tech, would be considered inefficient use of material. And that would be better. You can actually get very close. In fact, honestly, they can be on the same line. It's just going to burn a little bit more at that very in particular spot, but you can get pretty darn close, right? So for something like this, I could get closer and closer and closer and closer, again, to save some of that material, right, that is going to be left over no matter what. So again, maybe I'd make some copies of this, maybe put that on my chipboard. And actually, maybe the best efficiency for this is to kind of tool it together. I don't know, it's a weird, awkward piece. There's only so much efficiency. But clearly, it's right there. And I can copy that again in order to get my 8 pieces. But again, the same shape done in 2 different ways, and arguably doesn't really take the same amount. In fact, you may realize that even this method actually saves you chipboard compared to trying to unfold the entire piece.
Okay, I think I'm like a bit confused between score and cut.
Sure.
So cut is gonna do like the full outline, the actual cut all the way through, and score is like if you're bending something.
Correct. It's not going to cut all the way through.
Okay.
So it's going to basically only cut halfway. That way one side will basically rip and the other side will remain not cut. It's a really great question. I want to say that question again for the video. What's the difference between a cut line and a score line? And that's exactly right.
Okay.
Obviously, if you want the piece to come out of the piece, we need to make that outline in red and make sure that it's a cut layer, right? And that will essentially push the laser all the way through the material. Now, a score line is at half capacity just normally because of the machine. And yes, a score line will only cut through half of the material, but it'll only fold on that half too. It doesn't really like to fold the other way. In fact, as soon as you start to fold it the other way, not only does it look pretty inaccurate, but you also struggle. It's also cardboard, by the way. Chipboard is probably a little bit more forgiving in that sense, but it's a really good question. You know, what is the difference between those?
And it's not a requirement.
What is that?
It's not a requirement to have a score. Like if I have very orthogonal pieces, then I'm just
Exactly.
Okay.
Yeah, if you already have orthogonal pieces, and it's a good question because I do want to bring up a piece that maybe could be folded, but is still actually curvilinear and actually has a rectilinear part. So I kind of chose this object on purpose as well. This one where we have a cylinder and another piece. So again, we have curvilinear and rectilinear involved. So again, I want to show you guys both ways to do that. So in our case, let's try unroll surface first. Awesome. And as you can see, pretty crazy. Let's see. Oh, no, that's the piece that I want. Where'd it go? There it is. Oh my. Actually, there's like an entire, I mean, I could see an architecture floor plan in that. I don't know about you, but I love the computer, and especially when you make stuff that you didn't mean to. Again, I know I've probably explained this before, but I had this class in my master's studio where it was called the glitch studio, and your job was to make stuff that you didn't intentionally happen and to make something intentional out of it. And let me tell you, it was a fun studio because there'd be people like recording the screen with a VR camera, or you know, just making these really strange anomalies and making really art and other things out of it. But at the end of the day, you have to remember what we do is could be seen through an artistic eye as well. However, in my left brain, in my engineering mind, that will not work for the laser cutter. So let's try again. And in my case, maybe unfolding exploded might be something simpler to look at. So let's unroll that surface. Let's go ahead and explode it this time and see what happens. Not too shabby. To be fair, I really could 3D print this, or sorry, not 3D print it, but laser cut it. And yeah, I'd probably struggle a little bit, right, in certain cases. Another thing to keep in mind, remember how I just said, and again, this is why I only show this in computer graphics, because it does get a little tricky. I could explode this and actually set the folds myself. So for instance, maybe I do want to keep this rectilinear piece, right? So explode, of course spell explode correctly. And I could actually put together the ones that I know will fold well. So for instance, I'll put these two together, because I know right there, does that make sense? Right, I could just get that piece because I know I do want to fold it nice and perfect. However, I know the rest of it is curvilinear and I'll need to add some score lines to it. For some of you guys, you may have noticed, especially on like this one, you see there's actually a number of score lines on the edge so that it will bend easier. To be fair, you can do it either way. I do think it looks better and a little bit better craft and accuracy when you do start to show those lines. So I do want to show you how to make those. However, to be fair, some students just like, you know, bend it over a pole or a dowel, and you know, to be fair, that works too. But it doesn't look as good unless you have a really good crafted hand. But what I mean is, well, you can actually select certain parts in order to be folded. Well, that's not going to be a great fold there, right? Going from rectilinear to the other. So let's take, oops, undid my explode. So let's just take this piece, and arguably maybe that piece. That actually makes some sense. I could bend one inward and I can bend one outward, right? You could if the laser cutter cut on both sides, but we couldn't. So again, maybe that's not the right answer either. We just have to take this part and we're just gonna have to make this part in another way. So I'm gonna join those back together and unroll surface. I'm gonna not explode it this time. Enter. Go back to my top view. And voila, right? There's that piece I need. And let's get rid of this one. That way you guys, I mean, it's original, right? But yeah, okay, well, I have one part of it. Let's get the other part going. Sweet. And maybe I take this piece, that piece, and that top piece. Can't forget the inner piece as well. I can't tell you how many times students they get the outer piece, but they forget the inner piece, myself included. So let's try it. Join. So now we have technically two pieces. Obviously the rectilinear one and the curvilinear one. So let's unroll the curvilinear one. Enter. And it's getting a little more formidable. Obviously we're having an issue when it comes to the inner circle versus the outer circle. It's just not going to work. But again, what a wonderful composition for a floor plan, to say the very least. Let's try that again. So in my case, I got to explode it again. And maybe just do one piece at a time. So we'll take this one. We'll take that one. Let's try it. I mean, why not? We're scientists here. Unroll surface. But as you can see, it's a little bit more advanced. It's a little bit more confusing, but it works, right? So now I have this piece. Awesome. And that will basically essentially all be folded. Now we still need to make some score lines to it. And some of that stuff we do have to do by hand, so I want to show you an easy way to do it. But last but not least, we need our inner piece. So we got our outer. Let's get that inner piece and the bottom. So join those two as well. And again, unroll surface. So really the point of this video is sometimes you do have to be a little bit more advanced per object. And arguably, we could probably flip that and it'd still be okay. But clearly, it's just not going to work for that inner piece. So that's okay. We'll explode it again. And just take that piece out. So even if you didn't choose exploded mode, of course you can just explode it and continue the process. Now just to look at it a little bit deeper, from here I'm not just going to start making score lines. I definitely want to make that make 2D first, but get it as close as possible without confusing myself and without wasting some space. So to be fair, that would be that entire object now, but now it can be folded in two separate pieces and now put together. But let's make some score lines. So make 2D. Unfortunately, there's not like a magical way to just be like, score this. Or at least not one that I know of yet. But let's get it on the board. Oh, it's gonna fit just nicely. And I'm gonna put it in cut lines because I do want the entire extent of these objects to pop out, right? As was stated before. So change that to red. And really, like I said, we could just bend this piece, but another way to do it is to just simply take a score line yourself. And in my case, I have near on, my bad. Shouldn't do that. But I'll take one piece, move, and essentially pick some sort of regulating line. In my case, I would say the smallest that you want to do kind of a score, especially on, and it really depends on the size of the object, right? I would go with 1/8 or 1/16. So in my case, 1 foot, right? Because I do have to convert that. So 12 inches. And that might be too big, right? And you might have these like really big face panels, right? So maybe 1/16 would be better. So let's do, oh man, I got rid of my line. Let's get a copy in there. And go with 6 inches. And that might be a little bit better. Now from here, obviously we can array it. However, we don't also know how many pieces we need. So you might want to do it one at a time. To be fair, we also do this in drafting, where actually if we divide a line, so if we divide and we take this inner circle, you would essentially take each of these lines, and each of those lines represents a line going down for the score. Right, so I mean you could do this like drafting wise as well, and the way that you would do that is way more advanced but extremely accurate. You would take the center point. Oh, I gotta do the divide first, my bad. You'd take a separate line, you'd get your center, right? And this is where it'd get really tricky. You'd want to take that center and basically project these out. Same way that we do in graphics class. So if you really want to get it just perfect, obviously divide it and then take this measurement, right? So you could do DIM, just in case you didn't want to guess it and do 1/16, or so again, use 0.44 to get that exact spacing, right? But again, the more lines, the more accurate it is and closer that it gets to a circle. So again, kind of advanced. I would just go with the fake it till you make it method, but that's just me. So in my case, I'm just going to copy, make some score lines, copy again, because who wants to sit there and do that all day? And like I said, if you know that distance, right, that 0.44, then you can just array it, right, as many times as you want. You don't necessarily have to do this step. I just find this step to be a little bit more intuitive. But you'll notice it's not exactly accurate. If we did want to make that accurate, we still could. We would just take the number that we have, holding shift, and basically stretch it back down or scale it, right? You could also scale in 1D, so maybe just one direction or one dimension. So I can literally take this one, I could get the measurement that I actually need and bring it back. Right, so if I did want to make that even, of course you could. Now it's probably some arbitrary distance. Let's find out. DIM. But as you can see, we do have to do a little bit more critical thinking. And I got pretty close, 0.49 instead of 0.44. Who's going to know? Nobody's going to get a caliper to these models and be like, ooh, Esteban, I think it's 0.44 instead of 0.45, right? Nobody's going to do that in architecture school whatsoever. But again, if you're a perfectionist like I know a lot of us are, we know it's wrong. We know it's right. And those kinds of details start to add up when you start to really make a building. Don't get me wrong, nobody knows actually what's behind the ceiling except the guys who, of course, put it together. But they know they put their boogers on there. There's actually a famous story with Tadao Ando, I've told it before, where he was on site for one of his projects. And Tadao Ando is an incredible concretist, right? But he's kind of my body type, except 5'2". So he's very short, kind of looks like a kid. And well, he was on the job site and nobody recognized him. And one of the construction workers threw a cigarette butt into the concrete and was like, kind of laughing like nobody's ever going to see it. Tadao Ando came out of nowhere and beat the crap out of this guy, right? Because he knew what was inside of his material, inside of his building. Even though it didn't even make a difference, to him it did. You know what I mean? Like, I'm always going to know that there's a cigarette in that freaking wall. So, I mean, don't get me wrong. To him, it was like tainting the object. Even though nobody was going to see it, nobody would know. To him, it was still that information. Anyway, not to digress too much, obviously I still need to turn these into a score line. And I have one more object to go, at least for this tutorial. So I'd change that to a score. And I'm going to have a much easier time making this object perfect, right? To be fair, I also need to do it to this one. So might as well take the exact same dimension that I did, copy, and continue that one as well. I'm also going to have to study my object a little bit and ask myself, hey, does this part still curve too? Yes, of course that part still curves. And is actually going to meet up at the center point of the other one. So again, this is why I give you an entire week to do this part, right? Because honestly, just setting up this digital puzzle is half the battle. But once we have that, I can take this piece and just trim off the excess. To be fair, on the laser cutter, that would have no effect. I could score the rest of the board. It's not really going to have an effect. But again, there's that perfection information again. I'll know that it's not correct. But again, I'd want to get and make sure that I get every single piece here and trim it off. Now, obviously, I'd want to continue, but for the sake of tutorial, I'm going pretty quick. But now this piece is ready to be laser cut, right? And I'm going to have a lot easier time folding it and putting it together. Another way, just like I mentioned with the contours, you could probably do this in a contoured way too, arguably two different pieces, right? One's just going to be a circle with a hole in it, and at a certain point, I'm going to stop gluing and there's going to be one without. So in my case, let's try that contour method again, see what happens. Especially for really funky objects, and I'll see if I have a funky object to really get that point across. But as you can see, I'm not going to need a lot of pieces, and well, I got to put this back together real quick, my bad. Join, get rid of that one. And I may use 1/16 material, so contour again. Maybe let's do something smaller, like 6 inches. Sweet. So essentially I could laser cut all those layers now and actually glue them together to make a solid mass. Keep in mind, masses get heavy. And I know even in some cases, like D2, some people want to start making a mold or something. And I don't know if that's entirely necessary, right? But you could, right, by getting the inverse of this and, of course, just filling it with rockite, letting it settle, and, of course, tearing off whatever material you choose. So that is also an option. However, let's see if I have a funky object that... No, I don't. Do I have one? Did I ever make one? I didn't ever make one too funky, and I try not to just because to kind of persuade you from not doing so. But actually, here's a good instance where I could use the thickness of the material, right? So about 1 foot. Great. So I'll take this one and actually explode it, and just take one side of it. So I'll take this side, and I don't need that last piece, and I don't need this last piece because I'll be using the thickness of the material. I'll rejoin that together, just that piece, just so you can kind of see what I mean. It's kind of like this hollowed out piece. So instead of trying to fold all of that, like I said, this is the part that's actually going to look pretty bad when you try and fold that, right? It's going to be like crease, crease. So you might as well just fold a single solid material. Well, we can unfold a single surface as well. Unroll surface. No explosion, and voila, right? Of course we have that piece. You really shouldn't work in perspective, but once you get really good at three-dimensional space, you're okay. But as you can see, you can easily have floating pieces, and that's not going to work for the laser cutter. It does have to be at 0, right? So the best way around that is basically to flatten it or go to the top view. Can't express this enough, just make 2D. Maintain source layers, it'll of course remain the same. And now the one that it produces, of course, will be flat and at 0. So I'd get rid of that one, replace it. I don't know who needs to hear that, but it took me a while to realize, like, holy crap, I can just flatten things if I ever, you know, sort of not, if I ever have stuff floating. But anyway, we still need to make 2D this one, so make 2D. Sweet. But as you can see, it's missing some of the fold lines. So the best way around that is to explode this first, then make 2D. Nice. Now, of course, I'd make these two scores. Oh, gotta explode it. Probably gotta ungroup it. Ungroup, explode. Sweet. Score, score, and that's about it, because I do want it to cut out that window or that threshold. I do want it to cut out this shape, and of course I want to get the entire shape out of the material. So again, right click, change, take all these except these two, and of course change that to a cut layer. And that piece is ready to go. Now, to be fair, it does bend 2 ways, but, well, I could either score it on the other side or even make this so small just to kind of measure it for myself. So sometimes, especially when I know that I need to bend the other side, this is kind of, these are the tricks of the trade, actually. So what I'll do is I know it needs to bend the other way on this one, so I'll put it really close to the edge and I'll make it really, really small. That way nobody in the world has to know except for me. And I'll actually use it, that way the laser cutter gives me the accuracy. But now I know to flip it around the other side, kind of look, and set up my ruler there so I can score it too. Obviously just an X-Acto blade alone can give you a nice score line. So again, I can still get it, right? I don't necessarily have to put it on the laser cutter again, flip it over, and get another score line. I can get both sides just like that. Anyway, tricks of the trade. Any other questions? Any other interesting objects that you're like, how in the world do I make this? All right, fair enough. We'll leave it there for today. And obviously, if there's more questions, I can run through it as well. But really from here, guys, start making these objects. I'd really recommend, of course, starting with the topography. And seriously, I would glue last, right? Because you do want to kind of shape these into place. then glue. Otherwise, once you glue, it's kind of like crap. The holes aren't aligning something, right? I'd really make one of these pieces at a time, right? I'd work together on this one. And that's about it. We'll end it there for today.